Okay, so now that we've learned how to use the sample function broadly, let's apply it specifically to the bootstrap problem. So the first step in doing a bootstrap via this residuals method is to generate this epsilon star from sampling with replacement from the residuals. So this is how we would do that in R. If we have a vector of the residuals that I've named E, then I would just use the sample function and I would set the argument replace equals true, and I'm going to save this object as E star. The next step in the bootstrap procedure is to calculate Y star, and so that's going to be just our data X times beta hat plus epsilon star. And so X times beta hat, that's the same as Y hat, and so I can just plug in Y hat here. And then this epsilon star, we've just calculated here as E star. So I'm going to do Y hat plus E star, and I'm going to save that as Y star. So I've calculated my E star, which was sampling with replacement. I calculated my Y star, which is my new estimated Y value for this single bootstrapped sample. And now I'm going to compute my statistic of interest, which in this case is beta hat. And so I could compute this by just doing X transpose X, X inverse times Y star, and that would work. That would get me the beta hat that I need. Another way to do this in R is to use the update function, which I'm going to talk about a little bit more in a second. But this update function basically takes a model, so a model object, for example, from LM, and it updates the formula. So, for example, here, the part of the formula I want to update is the Y variable. Instead of plugging in my observed Y, I want to plug in this new Y star because I'd like to calculate my beta hats from my original X's still, but with this new Y star. And so that's what this syntax here denotes. So like we would normally write our formula where it's like Y tilde and then we'd add our X's after. If we just put a dot here, the update function will assume that we want our X's to stay the same. And so what this syntax does is it's going to update our Y value and it's going to use the original X value that we had put in our original model that was this first argument here. So I'm updating my model so that I've created a new model, and to get the beta hats from this new model, I can use the coef function to pull out those coefficients. Okay, so this is how we would do this once. To calculate one bootstrap sample and calculate one bootstrapped statistic, we would run this code. But what we actually want to do is we want to do this kind of more than once. And so what we can do is we can stick that code into a function, and if we ran this function once, it would run this code exactly like what we just did on the previous slides. But if we ran this function multiple times, it would basically each time generate a new bootstrapped coefficient. And that's ultimately what we want. So I'm going to step through this. For those of you not as familiar with writing functions in R, it's very easy. It's basically a matter of wrapping a set of R functions in a function call like this. And so I'm naming this function bootstrap underscore residual. And then I use this function, basically to tell R that I am building a function. And the arguments here are going to be the pieces or the components of this function that I'm going to pass in from the outside. And so I want to pass in my observed residuals. I want to pass in my observed Y hat. I want to pass in my original model. So this is the model fit on my original data, on my observed data. And then I want to pass in that data itself. So I'm passing in my observed residuals, my observed Y hat, my observed model, and my observed data. And so what happens in this function is because I'm passing these in, anytime I refer to each of those names, it's going to refer back to whatever I put into this function when I run it. So for example, here I'm going to be using this E that I passed into the function, etc. Okay, so the way that you name your function, you use the function here, you set the arguments of the function in parentheses, and then you open with the curly brackets and you close with the curly brackets. So that's the kind of structure of a function. Now let's step through each of these lines to talk about what they're doing. So I've made this a little bit bigger so you can see it a little better, but just to make sure that you're clear, there is an open bracket over here that gets cut off by the slide image, but the rest I wanted to make sure we could focus in on the inside of this function, which is why I made it a little bit bigger. But make sure when you're running a function like this, when you're writing one, you always have to have an open bracket at the top and a closed bracket at the bottom to define a function. Okay, so the first line of this function is exactly the same as the first line that we created previously when we were just running this once. And so we're going to sample from this this residuals, the observed residuals that we're passing. We're going to sample with replacement, and we're going to end up with E underscore star. And every time this is run, we end up with a slightly different E underscore star, because if you notice, I don't have a seed set inside my function. And that's good. We don't want the seed inside the function. We want the seed outside the function. Because each time the function is run, you want to get a slightly different answer so that you can basically get a distribution for these different values. But overall, you want the overall values to stay consistent from run to run. So if we were doing this 10 times, we would want the 10 values to be the same every time we ran it. But we wouldn't want all 10 in a row to be the same, because then we're not really doing bootstrapping, we're just sampling one time. Okay, so this is what that first line does. It samples that from those residuals. In the second line, I'm taking the y hat that I passed in through my function, and I'm adding the E star that I just calculated inside my function. And I'm saving this as a new variable in my data that I've passed. So this is my original data that I passed. I'm adding a variable called y star to that data. And then this is the same exact code as before. I'm going to use the update function to update my model that I'm passing in. So I'm passing this model in, and I'm going to update it so that the y variable is y star, and my data is going to be this data that I passed in. And again, just to remind you, that update function, it's going to update the model with a new formula. And so here I'm swapping out y from our original model with y star. And if you're curious to know more about update, you can always run $update in your console to read that help file. And then this very last part, instead of just writing the new mod, so taking the coefficients from this new model, I'm using the return function. I'm wrapping it in the return function. And it turns out for this particular function, that's not strictly necessary. This would still work if you just had the part that's on the inside. But in general, I think it's good practice when you're writing a function to explicitly say what you want to be returning. And so I often like to do that even if it's not strictly necessary. Okay, so what I want you to do is I want you to write a function like the one on the previous slide to perform a bootstrap. So I'm going to give you about 2 minutes to do that. In fact, you can go back and use that exact same function that I wrote, but I want you to add that to your application exercise because you're going to need that for subsequent questions. All right, so go ahead. Hopefully that function worked, and go ahead and knit your document and then continue on with the lecture. All right, so hopefully that function worked. So go ahead and knit your document and then continue on with the lecture.